Welcome students in this session of Metrology and Measurements course. So we have recorded the lab session for the demo, the lab session demo. This is a trial work we have done. So far this is the first time. So the demo of how to use that linear measurement instruments like Vernier caliper, Vernier depth gauge, and Vernier screw gauge. Okay, depth gauge, height gauge, not screw gauge. So I will show, this is the demo session. So this is a trial version. So in future we will upgrade the quality of the recording, and in future many sessions will be we are planning to record this live demo of how to use the instrument for the measurements, different what are the measurements available in our laboratory. So all the instruments are available in our laboratory. What we are studying in the syllabus, all the instruments are available in our laboratory, and we are planning to record the demo and upload in the YouTube, and for your understanding purpose we will share that video to you. So let's see this demo. So this is Vernier caliper. So we have seen this Vernier caliper in our second unit about the linear measurement. This is a direct measuring graduated instrument, mostly used for measuring length, thickness, and depth. These three things can be measured using this Vernier caliper, and you can see the component here. This is the Vernier scale. Okay, this is Vernier main scale. This is the main scale reading. This is the main scale reading, and this is the Vernier scale reading, and the Vernier scale division also we can say. And this is this jaws, inner jaw, and this is inner measurement jaw and external measurement jaws. And so this is fixed jaw. This is fixed jaw, and this is moving jaw, right? So we can measure the internal dimensions, mostly internal diameter, other things we can measure using these internal jaws, and using these external jaws we can measure the external diameter and other length values, right? And this needle-like structure is used to measure the depth of the specimen. So this versatile equipment is very basic and like lathe in manufacturing. So we will see the demo of how to use this equipment. Now you can see the least count. The least count is might be here. You can see 0.02 mm. This is the least count of this measuring instrument. That is the minimum value we can be able to measure using this instrument. So this is and this is a slip gauge of the slip gauge is a indirect measuring equipment. Equipment means this is a device, or we cannot say a device or equipment. This is a measuring system, and you can see this value of 80. It is engraved on this block, this slip gauge block. That is, it is standardized. This lengths are standardized, and we can compare. If you want to compare, so what is this length of this thing up to this to this? So up to this to this, it is the 80 mm length. For our comparison and for understanding purpose, we can able to now we perform a simple measuring exercise using this Vernier caliper. Our lab assistant Mr. Krishnan will perform this exercise. So please teach how to measure it. So first you have to fix it with the fixed jaw and you have to move the moving jaw. Then sir, so you have to tighten the screws. So now what is the reading, sir? Sorry to clean. Now you can see
main scale reading.
So the vernier scale and main scale reading are exactly that zero of the vernier scale is exactly coincide with the main scale reading. So now it is 8 mm. Correct? Correct, sir?
நம்ம வெர்னியர் ஸ்கேல் டிவிஷன் என்னன்னு பார்த்துக்கலாம். வெர்னியர் ஸ்கேல் டிவிஷன் இதில் கோயிங் சைட் ஆகுதுன்னு பார்த்துக்கலாம். 5ல கோயிங் சைட் ஆகுது. அக்யூரசி அளவு.
ஓகே சார். சொல்லுங்க சார்.
வெர்னியர் ஹைட் ஸ்கேல்.
This is main scale.
மெயின் ஸ்கேல்.
மெயின் ஸ்கேல் அண்ட் வெர்னியர் ஸ்கேல்.
இதில் பார்த்தீங்கன்னா இந்த சைடு மெயின் ஸ்கேல் ரீடிங் 0 1 2 3 4 5 இருக்குல்ல, இது மெயின் ஸ்கேல் ரீடிங். இது வெர்னியர் ஸ்கேல் டிவிஷன். வெர்னியர் ஸ்கேல் டிவிஷன் சேம் வெர்னியர் காலிப்பர்.
So sir is saying it is same like vernier caliper. So then
அலுமினியம் ஸ்பெசிமென் அலுமினியம்.
now sir is fixing
ஸ்பெசிமென் அலுமினியம்.
one second. Tell me sir.
ஸ்பெசிமென் அலுமினியம்.
Okay sir. So demos.
Adjustment screw. Adjustment screw.
Okay sir.
Main scale reading 0 1 2 3 4 5 6 ன்னு இருக்குல்ல, மெயின் ஸ்கேல் ரீடிங் இந்த 0 எங்க கோயிங் சைடு ஆகுதுன்னு பார்க்கணும் சார். 78 மெயின் ஸ்கேல் ரீடிங்
78.
மெயின் ஸ்கேல் ரீடிங் 78.
Okay.
வெர்னியர் ஸ்கேல் டிவிஷன் கொஞ்சம் சார்.
Now sir is checking where that vernier scale is coinciding with the main scale.
ஜீரோல தான் கோயின்சைட் ஆகுது வெர்னியர் ஸ்கேல் ரீடிங். ஆமாம் சார், அங்கே 10ல கோயின்சைட் ஆகுது. ஓகே 10 வெர்னியர் ஸ்கேல் டிவிஷன் 10. வெர்னியர் ஸ்கேல் டிவிஷன்
10 where 10. Okay. So now what is that reading? Total reading sir?
total is main scale reading plus main scale reading plus vernier scale reading into least count 0.02.
சொல்லுங்க.
main scale reading plus vernier scale division into least count 0.02 mm.
Okay.
That's the answer. Average.
Okay sir. So now we have completed that demo of this height gauge. So we have used the specimen with aluminum specimen.
This is surface plate.
So this is called surface plate. Mostly. So this is a surface plate usually used in the measuring and manufacturing units for the perfect flatness. So to avoid unnecessary undulations and surface defects. So for perfect flatness is needed for the accurate measurement. So the surface plate is usually used in all the measuring laboratories.
Components using vernier height gauge. இது போங்க apparatus record. படத்தை காமிச்சிங்க. படம் தான் முதல்ல காமிச்சிட்டிங்களா? படம் வேண்டாம், படம் முதல்ல காமிச்சிட்டிங்க. ஸ்பெசிமென் அலுமினியம் மெயின் ஸ்கேல் ரீடிங் எவ்வளோ சார்? 78 தான் சார்.
78.
வெர்னியர் ஸ்கேல் டிவிஷன்
10.
கரெக்ட் ரீடிங் மெயின் ஸ்கேல் ரீடிங் 78 ப்ளஸ் வெர்னியர் ஸ்கேல் டிவிஷன் 10
into least count.
Into least count 0.02. 0.02. Average.
போடுங்க சார், போடுங்க.
78.2 தானே?
எஸ் சார்.
78.2. அவ்வளோதான் சார்.
ஸோ திஸ் இஸ் சொல்லுங்க சார்.
மெயின் ஸ்கேல் டிவிஷன் ப்ளஸ் வெர்னியர் ஸ்கேல் டிவிஷன், வெர்னியர் ஸ்கேல் டிவிஷன் இன்ட்டு லீஸ்ட் கவுண்ட் 0.02. அது ரெண்டையும் ப்ளஸ், அது ரெண்டையும் பெருக்கிக்கணும். இந்த மெயின் ஸ்கேல் டிவிஷனை கூட்டிக்கணும். அது வர்றது ஆவரேஜ் ஆன்சர். அவ்வளோதான் சார். இங்கிலீஷில் சொல்லிடுறீங்களா?
அப்படி வந்து நீங்களே சொல்லுங்க. சொல்லுங்க.
வெர்னியர் டெப்த் கேஜ். Vernier depth gauge only for measurement checking depth.
தமிழ்ல சொல்லுங்க.
வெர்னியர் டெப்த் கேஜ் டெப்த் செக் பண்றதுக்கு மட்டும் டெப்த் கேஜ் நம்ம யூஸ் பண்றோம். நம்ம வெர்னியர் காலிப்பர்லயே டெப்த் செக் பண்ணிக்கலாம். டெப்த் கேஜ் ஒன்று தனியாகவும் வச்சு நம்ம டெப்த் செக் பண்ணிக்கலாம். இப்போ ஸ்பெசிமென் ரவுண்ட் ஷேப் cast iron, mild steel specimen, inner depth நம்ம செக் பண்ணலாம், அவுட்டர் டெப்த் நம்ம செக் பண்ணிக்கலாம். ரெண்டு டெப்த் நம்ம செக் பண்ணிக்கலாம். இப்போ இன்னர் டெப்த் இன்னர் டெப்த்.
ஓகே சார். ரீடிங் சொல்லுங்க சார்.
இது மெயின் ஸ்கேல் இது மெயின் ஸ்கேல் ரீடிங். இது வெர்னியர் ஸ்கேல் டிவிஷன். மெயின் ஸ்கேல் ரீடிங் எடுத்துட்டீங்களா சார்? மெயின் ஸ்கேல் தெரியுதா பாருங்க பையனுக்கு. மெயின் ஸ்கேல் ரீடிங்
சொல்லுங்க சார். என்ன வேல்யூ வரும்?
மெயின் ஸ்கேல் ரீடிங்
30
வரும் சார். மெயின் ஸ்கேல் 30க்கு மேல போகுது. மெயின் ஸ்கேல் ரீடிங் 32.
ஒரு நிமிஷம்.
மெயின் ஸ்கேல் ரீடிங் 32. Vernier scale division. Vernier scale division 3. Vernier scale division 3. Okay. Correct reading main scale division. Correct reading main scale division plus Vernier scale division.
So least count same.
Least count 0.02.
Okay sir. So the calculation sir. Calculation
in the diagram. Specimen name, specimen
steel,
mild steel. Main scale reading எவ்வளவு சார் வந்தது? 32. Vernier scale division 3. Correct reading main scale reading 32 plus Vernier scale division 3 into 0.02.
So 0.06.
0.02 na
0.06 வருமா?
0.06 வரும். இது ஒரு 32. 32.6.
30.06.
32.06 அவ்வளவுதான். இது ஆவரேஜ். இது பாருங்க. Any material, mild steel, brass, aluminum, copper, cast iron, ஸ்டெயின்லெஸ் ஸ்டீலு, ஹை ஸ்பீடு ஸ்டீல், எந்த மெட்டீரியல் வேணாலும் நம்ம செக் பண்ணிக்கலாம்.
Okay.
எனி மெட்டீரியல்.
So thank you, sir. Thank you very much for your cooperation. So we will upload more exercise like this with the help of Mr. Krishnan. So now in the previous classes we have learnt about the protectors, so universal bevel protectors, and in the angular measurement, that is in the angular measurement tools, second one is what we are going to see here is about sine bars. In the sine bars, so we are using the trigonometric principle. Now you can see the construction of this sine bar. This is a length of mostly the chrome steel, made up of the chrome steel, and this block having two rollers on these two edges, and you can see a hollows inside this block, chrome steel block. So these hollows will reduce the weight of this whole unit, and moreover we can use to hold this equipment, this whole system, they are set using these holes inside it. And these are the components of the sine bar. It's very simple instrument, but it will be more effective instrument to measure the angularity of many products and applications. So now you can see here how these sine bars are used, and with the help of the strip gauges we can measure the angle of inclination. For example, here you can see a specimen. So this is the angularity of this specimen can be measured with the help of this sine bar. You have to place this specimen over the sine bar surface, and that is here we have to should clamp properly. The clamping arrangements are not shown here because to understanding the purpose, a schematic diagram of this measurement only shown here. Don't confuse what will happen if that is block is, because it is sliding nature. If you keep the block, naturally a question will arise that because of the sliding and that block will slide down and fall. So but not like that. This is the schematic representation, and to give the understanding about the measurement. So we are placing the block that is going to be measured on the surface of the sine bar, and we properly clamped, and after clamping we will keep a dial indicator, and dial indicator needle will touch the surface of the block that is going to be measured, that is workpiece need to be measured, and we will increase, we will this is slip gauges. You can see the blocks, small rectangle blocks. These blocks are called slip gauges. Already we know that. What are the slip gauges? Slip gauges are standardized measurement blocks. So their length, height, and width, everything is standardized. There is no fractional. And dimension involving in the slip gauges. All are integer dimensions or whole dimensions only. So we can group under the indirect measurement devices or instruments, okay, slip gauges, because they are already manufactured to the standard dimensions. Already in the previous video we have used a 80 mm slip gauge to measure the to demonstrate a demo for using the Vernier caliper, right? So the predetermined heights, well, you have to add one by one. So while adding each slip gauges, you have to notice the movement in the dial indicator, right? If the movement of the dial indicator is nil, okay, the movement of the dial indicator is nil and it always points to 0, we have to stop adding the slip gauges, and we have to take the measurement. We already know that what is the total height of this slip gauge arrangement, okay, because each slip gauge height we know, and we have to add how many slip gauges we have arranged over it, and that is the H. Okay, this is total H, and we know the length. Okay, for example, these sine bars will come under 200, under 200, 200, and 400, 600, like some standard lengths they are available. So they will be maybe indicated, engraved on the slip gauges, or in the toolkit it is available that this is the 100 mm sine bar or 200 sine bar. So the length is also already known. This capital L is already known. No need to measure. If you want to measure also, you can use you can measure the diameter of these rollers, these two rollers, and you can measure the measure that we can reduce this. We can measure up to this edge to this edge along again with the vernier caliper, and if you add that this length plus the diameter, okay, diameter of this roller, you will get this total length. Through this also, if you don't know about the, or you are not very confident about the lengths, then you can use that methodology. So sine theta, this is the angularity. This angle is equal to the inclination present in the block. Okay, so sine theta, it is equal to h by L. So what's sine theta? So opposite side by hypotenuse. So opposite side is capital H and hypotenuse is capital L. So sine theta equal to h by L. So we can measure the theta by taking sine inverse of h by L. So this is the methodology we can use to measure the angularity of the components using the sine bar. So sometimes some measurements, this end also, some people will keep it over the slip gauges. Okay, some height, up to some height they will keep, and they will simultaneously add height here and simultaneously add height here. In both sides they will add height, and they will notice the reading in the dial indicator. When the dial indicator indicates the null point, that is 0 point, there is no deflection, means they will stop adding the slip gauges, and they will here. So they will measure that H2 minus H1. So what is the H2 minus H1 by this L. So like this also we can be able to do the calculation. So this is the dial indicator. You can see the setup here. You can see in this setup, this is that sine bar, and in this sine bar there are two rollers are present, and this is the object to be, angularity of the object to be measured, and it is placed on the surface of the sine bar, and that the slip gauges are kept beneath that roller, and this dial indicator will measure that differences in the flatness. If the dial indicator, up to where the dial indicator shows the null value, that is 0 value, or no deflection, up to that we have to add this slip gauge. Then we will measure this length. We already know the length, and we have to know, we can already know that we have to add or calculate the height of the slip gauge arrangement, and we can calculate the sine theta or theta by taking the sine inverse. So for large components, how to measure the angularity of the large components? The large components you can keep like this. This is the component, and over that we will keep invert the sine bar. Okay, we have to invert the sine bar and keep the sine bar over the large component. Previously, for measuring the small components, we will keep the components over the sine bar, but here in the large component, if we want to measure the angularity, we have to keep the sine bar over that component inversely, and we have to keep the height gauges. To use the height gauges and the dial test indicator. You have to fix the dial test indicator with the height gauges. So what is the dial test indicator is another set, another type of dial indicators. So dial test indicators are other type of dial indicators. So here the dial indicator is like this. So these same dial indicator and same principle, now it can be fulfilled by this instrument. It is called dial test indicator. And they should be kept over that height gauges, and we will measure. We have to instead of because the component is very high and huge, so we have to adjust the heights of these two height gauges. By adjusting the height, these zeros, we have to check the zeros value in these two dial test indicator. So when we have to stop the movement of these two height gauges, means this dial indicator should indicate 0. If the two dial indicators indicate 0, means then we have to stop the movement of these two height gauges. Then we will do the calculation. So this is R1 is height of that height gauge 1, and R2 is the height of height gauge 2, and divided by L. So this L, length of the distance between the center of the rollers of sine bar. So sine theta we can calculate using this formula, and theta is equal to sine inverse of R1 minus R2 by L. And this is this fiducial dial indicator. You can see the setup here in this height gauge. Over that we fix that this dial indicator it, and using this dial indicator we can measure the differences in the flatness. So sine centers also we can use. Sine centers are some it has some additional setup over the sine bar. So here we can firmly keep the component between these two anvils, okay, or two blocks, these centers like in the lathe. So it will keep fix that components very firmly. So for this advanced purpose and to improve the accuracy of the measurement, these sine centers will be employed. Now you can see here the cylindrical section, this conical work, it is firmly fixed between these blocks, anvil blocks, and now we can adopt the same methodology to measure that angularity and taper angle of this conical workpiece. So students, so in this I'm concluding this session. So from this session we have seen the demo of how to use the direct measuring instrument like Vernier caliper, Vernier height gauge, and depth gauge using the demo, and I have explained about how the sine bars and how to use the sine bars. So in future session I will explain the things, more details about other measuring instruments. Okay, thank you.